All right, today's lesson is on a new gas law. It's called Boyle's law. So this will be slightly different than the one you learned yesterday. And there's a new equation, and so I'm going to teach that to you now. If you missed yesterday, what I want you to do is take out a piece of paper and watch this video, and as you watch it, I want you to take these notes. All right? So this is going to be class notes on Boyle's law. All right, and Boyle's law basically tells us that if we increase the pressure on a gas, so let's say you got a container of gas and you increase the pressure on it, the volume of that gas will decrease. All right? So if you increase the pressure on a gas, then the volume will decrease. Now, if you think about that, it makes sense. Our graph, yesterday we drew a graph for Charles' law. We're going to draw a graph for Boyle's law as well. It's going to look a little bit different, okay? So our x-axis is going to be volume this time, and our y-axis is going to be pressure. So for Boyle's law, you can see that we're dealing with these two variables, pressure and volume. And what will the graph look like? Well, if we increase the pressure, then the volume will decrease. All right? So what that graph is going to look like, actually, is something like this. Okay? So, if you notice it, this is called an inverse relationship. Okay? So this is called an inverse relationship. Because if you look at this, you're increasing the one thing, and it's causing a decrease in the other. So they're kind of like responding in opposite directions of each other. So that's a little bit about Boyle's law, and now comes the equation. So the equation for it is pretty simple. Or the formula. All right, it looks like this. P1, V1, and remember, P is pressure, V is volume. So this is the initial pressure, this is the initial volume, is set equal to the second pressure, or the final pressure, and the final volume. All right, so these two on this side, these are kind of like the conditions in the beginning of the experiment, all right? And then you change something, and then this would be after. So this side is for the initial conditions, or the starting conditions, initial or starting conditions. Sorry, you can't see that. And then the other side is for the final conditions. And you'll see what I mean when we look at a problem, okay? So these are the initial conditions, these are the final conditions. Now, one thing that we noticed in class when we started doing problems is that there are some new units that we haven't talked about yet. So when we're talking about units of pressure, maybe you've heard on the news when they're talking about the pressure of the air, they call it the barometer. Air pressure is often given in millimeters of mercury. So you'll often see it as mmHg. All right, so that's millimeters of mercury. And that's a unit. You know, just like for temperature, how we have Celsius is a unit. So this is a unit of pressure. All right. Another type of unit of pressure that we often see is just called an atmosphere. Okay, and that's called 1 atmosphere. All right, so those are units of pressure. Now, next thing I want you to do is I want you to open up your student online packet. I've got a paper copy of it, but I want you to open up your atmosphere student packet online and find this activity. All right, Boyle's Law computer activity. And we're just going to kind of page through, scroll down, whatever you're doing, past all of these graphs until you get to the page that looks like this. And I'll zoom in there for you. So this is what you're looking for in your packet. All right, you're looking for this page in your packet. Scroll down until you find it. Pause the video. All right, so I want to do a couple of these problems. So we got to write the equation for Boyle's Law. So we're going to start right here. The equation for Boyle's Law is P1 V1 equals P2 V2. And again, sometimes you might see this as PI VI. That would mean the initial pressure and the initial volume equals, and then it might say PF VF. That'll mean final pressure and final volume. All right, so it says we can use this formula to predict the pressure or volume of any gas. Use this formula to complete the following calculations and show your work. So the first problem says, if a gas has a volume of 1.25 liters, right, that's the volume, and a pressure of, here's those units I was talking about, 1.75 atmospheres, what will the pressure be? So that's our pressure, our final pressure, our P2. What will the pressure be if the volume is changed to 3.15 liters? So that's my V2, right? This is my V1. This is my P1. All right, so you got all that stuff figured out. That's kind of an important step. And that's the P2. That's what I'm searching for. We don't know that. It says, what will it be? All right, so we're going to plug in our numbers to this formula, okay? So P1, 1.75 atmospheres, and keep your units. Sometimes I get lazy and I drop them, but I shouldn't. V1, 1.25 liters. By the way, if you drop your units, you won't get full credit. And that is equal to P2, which we don't know, times V2, which is 3.15 liters. All right? Now, can you just look at this equation? Can you just look at it and see, like, this is what you're solving for right here. If that's what I'm solving for, that means I kind of need to isolate that so it's all by itself. So how can I do that? Well, if I get rid of this by simply dividing by it, so divide this side of the equation by 3.15. 3.15 gets rid of it. All right, but then I've got to divide over here too. So divide by 3.15 liters. All right, and now what I've got to do is punch into my calculator, which I need to find my calculator. I got to punch in 1.75 times 1.25. All right, 1.75 times 1.25 equals, well, it would help if it was on, 1.75 times 1.25 equals, and now I want to divide that by 3.15. Divided by 3.15, and I get a final answer of 0.69. And what would my units be? So this is going to cancel out. My liters are going to cancel out and leaving me with atmospheres. And that makes sense because I'm trying to find a pressure. All right, so my answer is 0.69 atmospheres. And that is how I do that first problem. Now, what would really help, since we're having a quiz tomorrow, is if you take out your practice sheet from today. And if you were absent today, I'm emailing it to you. These are the Boyle's Law problems, okay? And let's do this first one together. So, again, you need your equation, and luckily they gave it to you right up in the corner there. So let me zoom in a little bit. I know you can't read this, but if you've got the worksheet, you're going to have it. Bacteria produce methane gas in sewage treatment plants. Lovely. This gas is often captured and burned. If a bacterial culture produces 60 mils of methane gas, all right, so that's a volume. If I see milliliters, that tells me that's a volume, okay? And that will be my initial volume. If it produces 60 milliliters of methane gas at 700 millimeters of mercury, that is, remember those are pressure, that's a pressure, that's my initial pressure. What would the volume be? What volume, sorry, would be produced? So I want to find a volume, that's my question mark, my V2. What volume would be produced at 760 millimeters of mercury? That's going to be my pressure final, or 2. All right, so set up your equation, P1, V1. So 700 millimeters of Hg times 60 milliliters, that's my volume. So this is P1 times V1 equals, my P2 is 760 millimeters of mercury times my my V2. I don't know what V2 is. I want to find that out. So again, just looking at this, I hope that you guys can see that you basically are going to multiply these two together, get an answer, and then divide it by this. Because I want to get rid of this on this side of the equation. I want to isolate this all by itself, right? So get your calculator out, and I'll show you, I guess, mathematically how you're supposed to do this. We want to get rid of the 760 on this side, so divide by 760 millimeters of Hg. All right, that's going to cancel that out. But then whatever I do on this side, I have to do on this side. So I want to divide by 760 millimeters of Hg. All right, so now you're going to punch into your calculator 700 times 60 equals, and then hit divided by 760 mm. All right, so here we go. 700 times 60, 42,000 divided by 760, and that equals 55.2 or 55.3. So my final answer, my volume is 55.3, and what would my units be in? Look, cross this out, cross that out, it's going to be in milliliters. All right, final answer. So open your email. I've got the answer key to this whole worksheet. All right, thanks for watching. Good luck. Bye-bye.